Hey everyone, welcome back, and today we're doing another Leetcode problem 669. Trim a binary tree. This is the medium one. Given the root of the binary tree and the lowest and highest boundaries such as low and high, trim the tree so that all its element lies between low and high. So these are our boundaries. A number less than low will be excluded or trimmed, you can say, and the number higher than high will be excluded also. And trimming the tree should not change the relative structure of the element that will remain in the tree, and any node descendant should remain a descendant. It can be proven that there are unique numbers, so there are unique numbers, and return the root after trimming the whole binary search tree. So we can see here that this is the binary search tree. So we know that we have the values on the left which are less than a certain node, so values on the right which are less than the certain node on the right. On the right they are greater, but on the left they are smaller. So like you can see in this example, 3 0 4 and 2 and 1, 2 is the descendant of 0, and on the left of 2 we have 1. So this is this example you can see, and let's just take this example for simple understanding. You can see that our range were 1 to 2 and 0 is not in our range, so we'll be just trimming it out. And now here we can see that 0 and 4 are not in our range, so we'll be excluding them, and our tree will be like 2 3 2 1. Okay, so that's it. So if we have our so we know that this is a binary search tree, and whenever we have a descendant like here, so if 2 had descendant of 1, and now it does have values like this, and 1 is the children of 2, and 0 has on the left -1, and we know that the range, our range is 1. Let me just write our range. So our range is 1 2 3. So we know that 0 is 1, so whatever on the left 0 is less than 1, so whatever on the left of 0 is excluded. So if there is a long binary tree here, then we will be excluding that, and when we have a less value than our lower range, then we know that we are going to the right, because there can be a value that is greater than this certain node with lying within our range. So it is true, yes it is true. So it is true 2, not true. So what we can do here is just go to the right. So if we have a higher value, then we know, so this is going to be the opposite case. If this was swapped, you can say, but not in the sense that it is swapped, like yes, this looks more like it, yes. If we put it here, so we'll be ignoring the left pass, because obviously 0 and -1 are not in our range, so straight away ignoring them and finding its right. It does not have a right, so we'll be going to the right of the 3, and to the right of the 3 we have 4 is excluded, and it is greater, so what we'll be doing is ignoring the right. So if there was 5, and on the 5 right we are going to have 7, things like this, we will be ignoring them, because we know for sure on the right of it is the value even greater than it. So that's it. So let's get started. So if there is not a root, what we want to do is just return none, and we will check if root does have something on its right, but also we will be checking that the root dot left, if the left value is higher than, not left, right, if it is higher, then we know that we are going to the right, so we'll be just returning. If it is higher, then we will be going to the right, left. If it is higher, then we will be going to the left, and if it is less, then we will be going to the right. So trim binary search tree by giving root dot left and passing it low and high. And if it is root dot val, yes I forgot to put dot val here. So if it is less than low, then we know that the values on the left of it are for sure even less than them. So trim BST will be passing it the right. So right and low and high. Okay, so now what we'll be doing is just taking the left and right. So left is equal to self dot trim root dot left dot low and low and high. So again copying it down, going to the right here. Okay, so now calling the function. So trim bst, passing it the root. So that's it. After that we can just return the root, not calling the function because obviously we called it in the recursive call. So then we're just passing the root. This works and that's it.